Hi, this is Mrs. LaBarbara. Today's lesson is Freefall and Acceleration of Gravity, Part 2 Equations. The objectives for today is to be able to solve freefall problems using equations. First, let's review all the equations we have learned. So by definition, average velocity is total displacement divided by total time. We can find average velocity using initial plus final divided by 2. Again, this equation is only valid if acceleration is constant. By definition, acceleration is defined by change velocity by time. After we rearrange this equation, this is what we have. Vf equals Vi plus At. This is A, in this case, is average acceleration. So the last two equations are only valid if acceleration is constant. Kinematic equations in freefall. So there are a couple of things we need to pay attention in freefall. First is acceleration is negative 9.81 meters per second squared. So acceleration is constant on Earth's surface. This negative means it's downward. Number two, object is merely dropped from elevated height, then the initial velocity is 0. So Vi equals 0. Number three, if an object is projected upward in a perfectly vertical direction, then it will slow down as it rises upward. The instant at which it reaches the peak of its trajectory, its velocity is 0. This value can be used as one of the motion parameters in kinematic equations. For example, the final velocity after traveling to the peak would be assigned to a value 0 meters per second. Number four, if an object is projected upward in a perfectly vertical direction, then the velocity at which it is projected is equal in magnitude and opposite in sign to the velocity that it has when it returns to the same height. For example, if a ball is projected vertically with an upward velocity positive 30 meters per second, we'll have a downward velocity of negative 30 meters per second when it returns to the same height. In this process, the total displacement is 0. So all these values are important. They are like hidden values. We need to write it down. Let's take a look at an example. A clam dropped by a seagull takes 3.0 seconds to hit the ground. What is the seagull's approximate height above the ground at the time the clam was dropped? So to solve problems, we use the same procedure, which is IC. I means that to identify, write down what you know. So let's see, dropped means initial equals 0. Next value is the time. Because it's a free fall, we know acceleration is negative 9.81. And what is the displacement? Here is one thing. Whenever you know three values, you can figure out the rest using the equation. Look at your equations, see which one you can come up with to solve D. This is the one that you can use to solve D. In this equation, you know all the values except D. You know Vi, you know T, you know A, you know T. So D is the only unknown quantity. Execute means to substitute and solve. As you can see over here, you probably get confused. How can height be negative 44? Let's see, in this equation, D does not mean height. D means displacement. So the clam is displaced downward, negative 44 meters. What does that say about height of the clam? The height of the clam has to be 44 meters. Another example, Miss E. DeWater, the former platform diver of the Ringling Brothers Circuits, dives from a 20-meter high platform into a magic bucket of water. Use kinematic equations to fill in the table below. Show your work below for one of the rows of the table. So basically, what is given to you in here? You know initial velocity is 0. You also know the time. Because this is a free fall, so you also know acceleration. So you know three variables. From those three variables, you can figure out everything else. Take a look at the first one. You know the initial velocity and acceleration, and you also know the time. So you know you can use this equation to figure out the final velocity. At 0.5 seconds, v equals to vi is 0 plus negative 9.81 times 0.5. So solve it, you should have negative 4.9 meters per second. Negative means the diver is moving downward at that moment. How do you find velocity at 1? You use the same equation. Again, from 0, you took 1 second. What is that velocity? So basically, you use the same equation, you substitute a different value for time. Similarly, you can do 1.5 and 2. How do we find the distance? Again, you know initial velocity, you know the time, you know acceleration. So this is the equation to use for displacement. So this, the displacement is this, after you substitute in, actually is negative 1.2. And over here is negative 4.9 and negative 11 and negative 19.6. But this one is asking you the distance fallen. So distance has to be positive of your corresponding number. Last column is the height. How do you find the height? Let's see. The diver start from 20 meters. So in 0.5 second, the diver had fall 1.2 meters. So what is the height of the diver at 0.5 second? You subtract these two numbers. 18.8 meters. What is the height of a diver at 1 second? You subtract 20 and 4.9. So you should have 15.1 meters. And similarly, you'll get the rest. Another example. A 5 kilogram sphere starting from rest falls freely 22 meters in 3 seconds near the surface of the planet. What is the acceleration due to gravity near the surface of the planet? Let's see, what do we know? You know from rest, initial velocity, it falls freely. Acceleration is negative 9.81 meters per second. 22 meters, this should be negative. Why should it be negative? Because you're falling downward. And another thing you know is the time. So you actually know 4 things. Initial velocity. Oh, you don't know the acceleration, so you have to find acceleration. So let's see, you know 3 things: initial velocity, time, displacement. You have to find acceleration. Look at the equations, substitute, and does the answer make sense? The answer should be negative. It should be less than 9.8. Because in 3 seconds, remember we did before, on Earth, it falls 44 meters, not so this one should be smaller than 9.81. Another example, a 3 kilogram mass is thrown vertically upward with the initial speed of 9.8 meters per second. What is the maximum height this object will reach? Here is a hint. Maximum height, its velocity is 0, so that's VF. VI is 9.8, VF is 0. This didn't say another planet, so it's Earth. What is the height? D. So in this part, we don't know the time. Whenever you don't know the time, there is one equation called timeless equation. That's the equation you use. So you solve for D, substitute in. This is the number you should have. Does that make sense? Well, yes. Because remember how velocity change by 9.8 meters per second every second? So it takes about 1 second for it to reach that height. And that is the distance it moves in the first second, 4.9 meters. Now let's see, you'll have to find acceleration due to gravity on the planet. So let's see what do you know? Initial velocity is 0, total distance falling negative 0.72. Another thing you know is the time. So how do you find acceleration? Equation, execute, and evaluate. Does that make sense? An astronaut standing on the platform on the moon drops a hammer. Initial velocity equals 0. You know the time and the distance. Time is 2.7 seconds. Distance is 6 meters. Displacement should be negative 6 meters because it's falling down. What is the acceleration? So as you can see, it falls 6 meters in 2.7 seconds. So you know acceleration should be less than 9.8. So that's C. Write down what do you know? Use the equation, substitute a value. Does this make sense? It does, because that is about 1.6. That is the acceleration on the moon. Okay, let's take a look at another one. 1.0 kilogram ball is dropped from the roof of a building 40 meters. What is the approximate time of the fall? So you know initial velocity, you know displacement, you know acceleration. So how do you find the time? Look at the equation you use is this, okay? So VI equals 0. The first term is 0. You solve for t, square root of 2d over a, and substitute, that's what you have. By the way, if you forgot this negative on the calculator, you will have an error. When you have an error, that does not mean you should realize what you did wrong is the sign, okay? So and evaluate. So the answer makes sense. I think that's it for today. Thanks for watching. See you next time.